Hello, welcome friends. Me Anila. The topic of my discussion is about numericals on equilibrium constant and quadratic equations. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how we will solve the numericals on equilibrium constant. Equilibrium constant is a constant in those reactions that are reversible. Reversible means forward reaction and backward reaction is occurring. So at equilibrium, we can calculate equilibrium constant by equilibrium concentrations. And quadratic equation we will use for the formula of x. Example number 1. Equilibrium constant for the following reaction is 4 molar. Initial concentration for A and B are 0.2 molar and 0.2 molar respectively. Find the concentration of A and B at equilibrium. A is giving product to B. In this example, A is reactant, B is product. 1 mole of A is producing 2 mole of product B. So the equilibrium constant for the reaction is given 4 molar. Initial concentrations of A and B are 0.2 molar, 0.2 molar. We have to find the concentration of A and B at equilibrium. Firstly, solution. Equilibrium concentration for A is, the initial concentration of A is 0.2 molar. So some amount of X is converting into product. So the equilibrium concentration for A is 0.2 minus X. We have to find this value. Equilibrium concentration of B is 0.2. 0.2 is the initial concentration plus the amount of X that is released by A is converted into B. It is 2X. So 0.2 plus 2X is the equilibrium concentration for B. We have to find equilibrium concentration for A and B. So this is the formula of Kc is equal to product, that is B, and the coefficient of B appears as power 2 divided by concentration of A reactant. So we will put the value of B at equilibrium concentration 0.2 plus 2x square. We will put the value of concentration of A 0.2 minus x is equal to 4 is the value of Kc. Now 0.2 plus 2x whole square. As you already know, when A plus B whole square is equal to A square plus 2AB plus B square. In the same way, 0.2 plus 2x square is equal to 0.2 square would be 0.04, 2AB would be 0.8x and B square would be 4x square. This is equation 1. Now put this value in Kc expression, we get 0.04 plus 0.8x plus 4x square is equal to 0.2 minus x into 4. Now we will solve these equations. Next is 4x square plus 4.8x minus 0.76 is equal to 0. We have to put all the values on left side so that on right side it would be 0. Now we will apply quadratic formula. For quadratic formula we need A, B and C. Here A is equal to 4, B is equal to 4.8 and C is equal to minus 0.76. So we will put these values in quadratic formula. Applying quadratic equation. This is quadratic equation. You have to memorize this equation. X is equal to minus b plus minus root b square minus 4ac divided by 2a. This is quadratic formula. As I have discussed earlier, the value of a, b and c we have calculated. Now we will put the value of a, b and c in the quadratic formula and get x is equal to minus 4.8 plus minus b square 4.8 square minus 4 into 4 into minus 0.76 divided by 2 into 4. So we will put the value of a, b and c in the quadratic formula. After solving, two values appear x. One is negative, one is positive. We know that x is a positive value that has converted into product. So x is equal to 0.14125 molar. We have calculated x. Now we have to calculate equilibrium concentrations of A and B. As I have discussed earlier, A is equal to zero point 0.2 minus X is equal to zero point 0.2 minus, put the value of X, 0.14125, answer comes 0.058 molar. In the same way, concentration of B at equilibrium is 0 0.2 plus 2x is equal to 0 0.2 plus 2. We will put the value of x, 0.14125. Answer comes 0.4825 molar. So at equilibrium, concentration of A is calculated to be 0.058 molar. Concentration of B at equilibrium is calculated to be 0.4825 molar. Example number 2. For the following reaction, calculate Kc if equilibrium concentration for A and B are 0.447 molar and 0.05 molar respectively. This is the reaction. 2A is producing B product. So we have to find equilibrium constant for this reaction. Equilibrium concentration of A and B are already given. In the example 1, the initial concentration are given. But in example 2, equilibrium concentration are given. So it's simply the easiest way to calculate Kc. Solution. Kc is equal to, here product is B, concentration of B divided by concentration of A square. The coefficient of A becomes square is equal to, put the value of B 0.05 divided by, put the value of A at equilibrium 0.447 square. After solving, Kc is calculated to be 0.25 molar inverse. The unit is molar inverse because the concentration of B has molar and concentration of A is molar square. So molar cancel and we have molar inverse. So 0.25 molar inverse. Example number 3. For the following reaction, calculate Kc if equilibrium concentration for A, B and C are 0.316 molar, 0.316 molar and zero point 0.4 molar respectively. A plus B gives us product C. So this is also a reversible reaction. For this reaction, we have to find Kc. As I have discussed in example 2, the similar is the case in this example also. Equilibrium concentration of A, B and C are given. We have to find Kc. Solution. Kc is equal to product concentration divided by concentration of A into concentration of B. These are reactant concentration at equilibrium. We simply put the value of concentration of C 0.4 concentration of A 0.316 into concentration of B 0.316 at equilibrium. After solving, Kc is calculated to be 4 molar inverse. Here also the unit of Kc molar inverse because concentration of C is in molar, concentration A and B are in molar. So molar cancels. The unit of Kc is molar inverse. Friends, if you have any question, you can ask me on comments. I can help you. In this way, we can calculate equilibrium constant and equilibrium concentration of reactant and product at equilibrium. Friends, you can ask me any question. I can help you. Thanks.